Hello. In VHDL programming, in VLSI design and technology, another practical, second practical, here 4-bit bidirectional shift register. In VHDL programming, VHDL is a very high-speed hardware description language for integrated circuit. In VHDL contain three modeling styles: data flow, behavioral, and structural. In VHDL programming contains three data objects: signal, variable, and constant. Okay, experiment number 2, 4-bit bidirectional shift register. Shift register here, advantage of shift register, application of shift register in microprocessor. Shift register data shift, serial output, serial input, parallel output, parallel input, serial output conversion. Okay, here VHDL programming for 4-bit bidirectional shift register. Here control signals, shift oblique load bar. When input is applied logic 1, then data shift this particular of the data shift right side, then data shift left side also. Okay, your input is applied here, then this data shift through this particular of the AND gate, then through this OR gate, then input is applied to the another flip flop, and data shift here right side and data shift left side also. Okay, this is behavior of 4-bit bidirectional shift register. Here in this VHDL program for this second experiment, 4-bit bidirectional shift register in behavioral modeling style. Okay, the behavioral modeling style means here you know the behavior of 4-bit bidirectional shift register. Then you write VHDL program for 4-bit bidirectional shift register. Here Q3, Q2, Q1 and Q0 output of 4 flip-flops D3, D2, D1 and D0. Okay, so here D flip-flop and the D flip-flops output here Q3, Q2, Q1 and Q0. Initially this flip-flop output initially 0, 0, 0. Okay, first clock cycle is applied and here direction is logic 1 and DIN input is logic 1. Then logic 1 shift in Q3. Okay, then 0 shift previous data of Q3 logic 0 shift in Q2, then Q2 data shift in Q1 and Q1 shift in Q0. Then second clock cycle is applied, then again logic 1 shift in Q3, then again this logic Q3 data shift in Q2, Q2 shift in Q1, Q1 shift in Q0, then third clock pulse is applied, again here 1 1 1 0, and fourth clock cycle is applied, then logic 1 shift here Q3, Q2, Q1 and Q0. After that, your direction change logic 0 and DIN input also change, suppose logic 0. Okay, initially this flip flops output data here 111. Okay, and first clock cycle is applied, then data shift here right to left. Okay, so logic 1 is shift in Q0, then after that here Q0 previous data shift in Q1, Q1 data shift in Q2 and Q2 data shift in Q3. Then second clock is applied, then logic 0 is shift in Q0, Q0 data Q0 here previous data Q0 is shift in Q1, then Q1 data shift in Q2, then Q2 data shift in Q3, then third clock cycle is applied, then here 100 and here fourth clock is applied 000 data shift in this particular of the shift register. This direction 1 data shift from left to right and direction 0 data shift from right to left side. Okay, this is behavior of 4-bit bidirectional shift register. And next here VHDL program for this 4-bit bidirectional shift register. The first line is library IEEE. Then you mention use IEEE.standardlogic 1164.all, the name of package, and that package contain your input data type is standard logic, that related information is contained in standard logic 1164.all. Name of entity shift is port clock comma reset comma din comma dir in standard logic. Okay, clock input, reset input, din input and direction input, and that only one bit input on this uh, on that particular signal, and mode is in and data type is standard logic, and q out standard logic vector 3 down to 0. Then end, name of entity, shift is. The next line, architecture, name of architecture of shift is. Okay. Here signal QA, internal signal, you take additional signal is QA, standard logic vector 3 down to 0. Okay. Here why here additional signal is required? Because in this shift register, data QA3 assigned to the QA2, then QA2 assigned to the QA1. Means here QA3 output mode, then QA2 input mode. After that, next line QA2 is output mode. Means here this particular of the Q output here work as a bidirectional. But in entity already Q is mentioned out, mode is out, standard logic vector 3 down to 0. But in this architecture, here operation is bidirectional on Q signal, and hence you change the signal name Q to QA, signal QA, standard logic vector 3 down to 0. Then begin process clock comma reset. Process statements contained in this behavioral modeling style, and in front of process contains sensitivity list, clock and reset. Clock input and reset input is changed, then this process executes. Okay, after that begin words. If reset is 1, reset signal is 1, then all flip-flop output is initially 0, 0, 0. Okay, after that else if means here reset input is 0, then all flip-flop work as a normal flip-flop. And here clock tick event and clock is equal to 1, then clock tick event and clock is equal to 1 means positive edge triggered clock signal. Then if direction is 1, your direction is 1, then DIN data assigned to the QA3, QA3 data assigned to the QA2, then QA2 data assigned to the QA1, QA1 data assigned to the QA0, and else. Then else statements means direction 0, okay, and your DIN input is logic 0. Means QA2 assigned to the QA3, QA1 assigned to the QA2, QA0 assigned to the QA1, and DIN assigned to the QA0. The direction is 0, then data shift this right to left side, direction 1, data shift from left to right side. Okay, this is bidirectional shift register. Two if statements, here if and here if statement, end if, then end process, and after completion of this process, then QA is assigned to the Q. Okay, Q is your output signal and QA is your internal signal. So internal signal data assigned to the Q, and then end name of entity, name of architecture. Okay, so here complete VHDL program, and here simulation result of that 4-bit bidirectional shift register. Okay, and here this complete 4-bit bidirectional shift register program I will perform in Xilinx software. Okay, Xilinx VHDL software. Okay, so here I will share. Wait a minute. Okay. Here. Okay, you click on this ISC design 4.14.2 version of the Xilinx software. You click on OK button here. You select file, file. You click on new project, and file name is SHIFT shift. Okay, file name is shift here. Then you click on next button. Then here family name Spartan 3 device XC3S500E, and then package PQ208. Then you click on next button, then finish. Okay, you click on this shift, right click, new source, VHDL module. Okay, here file name, then you next button, then again next button, then finish, and then you write your VHDL program here, the high speed hardware description language for integrated circuit. Okay, so this VHDL program, okay, uh, you check syntax of this VHDL program, you click on check syntax. Okay, syntax is correct. Then next step, here you click on simulation, then here you click on this shift.vhd. Okay, you click here behavioral check syntax, and then simulate behavioral model. Simulate behavioral model. Okay, this window. Okay, here input is applied, there is clock signal. Okay, you click on clock signal, right click, then force clock, you click on force clock. Leading edge is logic 1, sorry, this leading edge is logic 1, trailing edge is logic 0. Here period is 1 nanosecond time period, and you click on apply and OK. After that, you apply reset. So reset input is applied logic 1. Initially your reset input is logic 1, out flip flop output is 0, and then your input bit logic 1 is shift. Initially reset input is logic 1. Okay, DIN input here logic 1, here logic 1 apply, and direction initially logic 1. Direction is logic 1 apply, okay, and then you run this program. So here in this, initially all flip flop output is 0 0 0, then reset input is logic 0, then the shift register with all flip flops work as a normal flip flop. Then you click again. Okay, so data here shift register, working of shift register I will explain here how to shift this particular of the data. Initially all flip flop output is 0 0 0. Here you observe here first clock is applied, then here logic 1 is shift, second clock is applied, then 1 1 0 0, then triple 1 0, and 4 logic 1. Okay, so here initially 0 0 0 data, then one first clock cycle is applied, logic 1 shift towards the right side, then 1 1 0 0, then triple 1 0, then 4 logic 1. Okay, after that here DIN input is logic 0. Okay, the DIN input is logic 0, apply, and direction also you change logic 0, force constant, here logic 0, apply, okay, and then you run this button. After run this button, then this data shift from this particular of the right to left side, direction change, and DIN input also logic 0. Here the first clock cycle is applied, 0 triple 1 0 0 data shift from right to left. After that 1 1 0 0, then 1 0 0, then 0 0 0. Okay, so this is bidirectional shift registers simulation result. Okay, after that you observe this VHDL language is a hardware description language. RTL schematic also you observe here. Synthesis, after synthesis this VHDL language is converted into SOP equation, and then hardware also generate view RTL schematic. This is hardware description language. Okay, hardware is generated here. In this 4-bit bidirectional shift register, hardware also generates in this particular of the 4-bit bidirectional shift register. Okay.